Welcome, everyone. For today's prep, we're going to be looking at a new integration technique called integration by parts. And for today, we're going to be looking at just indefinite integrals. So let's get to the main result here, the big formula. And as we'll look at where this formula comes from in class, but kind of with substitution rule we saw really comes from the chain rule, the derivative chain rule. Integration by parts is going to be undoing our derivative product rule. So this formula should have kind of like a product rule feel to it. All right, so let's read through it, and then we'll see how this process works. So integration by parts formula says the integral of u dv is equal to u times v minus the integral of v du. And kind of how we apply this formula is this is the integral we're usually trying to do, and it's more complicated. And by applying this formula, we get a piece that's already integrated, and then hopefully this remaining integral here on the other side is a bit easier to do. All right, so when we go through this process, the u and dv and the u and the, all these little terms here, these are kind of stand-ins for x terms. So usually our integral will be in terms of x. And our first step is to identify what we want to call u in our original integral and what we want to call dv in our original integral. So that's usually the first step. Choose u and choose dv. All right, so once we have those two things chosen, then for u, we're going to calculate du. And we do that by differentiation. So we're going to take whatever formula we chose for u, and we're going to differentiate it to get du. So this is going to kind of have a lot of the same feel as substitution rule, a lot of the same kind of things here. But then we also have this dv. So with dv, this is the differential of v. So we want to figure out v, and so we want to undo the derivative there. So we're going to use integration. So once we have those four pieces calculated, then we're going to use this formula, and then this integral on the other side still has to be calculated. But hopefully by this point, it's something that we can do. So let's try an example and see how this process works. And we're going to we'll talk about product rule in class. So let's look at something easy. Example 1. We've got this function x times e to the x dx. We want to integrate this thing. And we're going to use this integration by parts technique. So the first step is we have to choose u, and we have to choose dv. So we'll go into the strategy on how to do these things. But for right now, I'm just going to say. So we're going to choose u to be x. And we're going to choose dv to be everything else in our integral. So we're choosing u to be x here, and we're choosing dv to be the leftover terms, the e to the x dx. Okay, so that's the first step. We choose those two things. Then we're going to calculate the differential. So we're going to differentiate our u term. So the derivative of x is 1, and then we multiply by dx. So we get 1 times dx, which we don't normally write 1 times. And then we want to integrate here. So we're going to integrate this to get v. All right, so if we integrate both sides of this equation, the integral of dv is just v. And then the integral of e to the x, nice and easy, is e to the x. Okay, so once we get these four ingredients, we're ready to apply our integration by parts formula. And a way to remember the formula is kind of with a backwards Z shape. So if we multiply these two terms together and integrate, that gives us our original integral. So what that integral is equal to is u times v. So we can multiply these two terms together. So x times e to the x. And then minus the integral of those last two terms. So minus the integral of e to the x times dx. So we multiply our e to the x times dx. That's what we're seeing here. And we're integrating. So this is, one way to remember the integration by parts formula. So once you have these four ingredients written down in kind of this particular order, it's like a backward Z. So multiplying the u and the dv together and integrating gives us our original integral. So that's what we're seeing right here, just our original integral. And then multiplying the x and the e to the x here, that's multiplying our u and our v. And then finally, multiplying our v and our du together is giving us, and then integrating is giving us this last term. All right, so the upshot of this is we've taken this more complicated integral. We have this piece that we're done with, and now we have this other integral to do, but this one's a little bit easier. So here we're just integrating e to the x. This one had x times e to the x. So then we just finish. So the integral of e to the x is just e to the x. And then we throw on our plus c. So let's going back. We can remember this formula by multiplying those first two terms together and integrating. And that gives us this kind of first term. Then we can multiply down the main diagonal here, so u times v. That gives us this next term. And then finally, if we multiply the last two terms together, the v and the du, well, that's what we're seeing here. And to complete the formula, we're subtracting that integral. So again, it's this kind of backward Z shape if you think of it that way. All right, so let's try one more example. So let's look at example 2. So we have this function. It's the integral of 2x plus 5 times sine of 3x, and we wanna integrate this thing. All right, so again, for right now, we'll get into the strategy in a little bit. But right now, let's go through the process. So we're going to choose u, and our choice for u here, I'm just going to say it, is 2x plus 5. And then we want to choose dv. And so once you've chosen u, your hand is kind of forced. So dv just has to be then everything else in the left over. So since we already made this our u, then everything else is going to be our dv here. So sine of 3x dx. All right. So we have the two pieces. We still got to get the other ones. So we're going to differentiate our u term. So let's see what we get. So the differential du, derivative of this is 2, and then we multiply by dx. And then over here, we have dv. We want to get v, so we're going to integrate. So integrate both sides. Integral of v dv is just v. And then we want to integrate this sine of 3x. And this is one of our special k-forms that we mentioned with substitution rule. So the way we integrate a k-form like this, we could go through the substitution rule perfectly fine, but it's probably going to be better now to have these memorized. So the integral of sine is negative cosine. So I'll put the negative in front, and then we'll have our cosine. We keep the inner function the same, so it'll be just cosine 3x. And this is a k form, so we take that constant k that's in front of our x, and we flip it and put it in front of the trig function. So the antiderivative of sine of 3x is negative 1/3 cosine 3x. All right, so we've got our pieces. So now we're ready to apply our integration by parts formula. So again, multiplying these two terms along the top here and integrating, that's the original integral that we want to do. So the integral of 2x plus 5 times sine 3x dx. Now the way the formula works is that original integral is equal to, we can multiply down the main diagonal here. So let's see what we get for our u times v. So we have, and while you're multiplying these things, maybe rearrange the terms a little bit. So we're going to have this negative 1/3. I'm going to write that first. Then we have the 2x plus 5. I'm going to put that next. And then we've got our cosine 3x. So just to get to range the terms a little nicely, I like to put the constant multiple, especially if it's negative, out in front so that we don't get that confused with subtraction. Okay, so this is our u times v. So that's what this is. So then we're going to subtract and integrate, and then we multiply those terms along the bottom here. So for those terms, we're going to subtract and integrate. And again, it's going to be v times du. And while you're doing this, multiply the constants together. So we've got this negative 1/3, and we've got a 2. So let's multiply those together. So we'll get negative 2/3. And then we've got our cosine 3x. So I took the negative 1/3 and the 2, multiplied those together. Then we've got our cosine 3x, and then finally we have our differential at the end. So dx at the end there. And we're just about there. We still have this one integral to do, but this integral now is easier. This is just a k-form integral, so we can just do it. All right, so let's, and maybe before we actually go through, maybe it's worth just simplifying this. So with integration by parts, you kind of end up with a lot of negatives. So as you go along, it's probably a good idea to simplify any negatives. So we'll have our negative 1/3, 2x plus 5, cosine 3x, and then this will be plus 2/3. And let's get the antiderivative of that cosine 3x. So again, this is just another k form. So the antiderivative of cosine is sine. For a k form, we keep the inner term the same, so it's going to be sine of 3x. And then also for a k form, we take that constant k that's in front of our x there, we flip it and put it in front of the trig function. And again, that 2/3 became positive because of the double negative. And that's it. And we don't want to forget our, since we're doing an indefinite integral, we don't want to forget our plus c there at the end. All right, so that's the idea with integration by parts. And as we'll see, we'll talk about the strategy. Where this gets difficult is how do you pick U and how do you pick dV? And there's kind of an acronym that we'll mention on how to help remind you for how to choose these things. So we'll see you then. Bye-bye.